Hey guys, what we have here is a Fender Princeton Reverb, and this video is mainly just for the client to see what he had, what was done to it, and how we're going to bring it back to the original way it was originally wired. I'm just going to go from left to right and try to bear with my camera skills. Okay, starting out, if I can get a good look at it. Okay, this here is the negative bias supply, and it's got kind of a weird trimmer in here and a resistor, and it's got a 100 UF cap, 100 volt, old diode, metal diode. Okay, so this is going to get rebuilt. This trimmer is going to go away. We're going to have a regular trimmer in here just to show you what it will look like. We have the cap here, resistor, diode, and it goes to a trimmer over here with a tail resistor to ground. So this is what we'll have instead of this stuff here. This is all going to get replaced, and then these are the filter caps. They've been changed from the can cap was cut out, and they put in the 4 filter caps. We're going to switch them to F and T's, and I'm actually going to stack the 2 on top of these 2 and have the 18K carbon comp here and here drop-in resistors going to be changed to metal oxide, and these 2 caps will be on top here. That way there'll be room right here for that bias trim pot. One other thing is, and I don't know if we're gonna get the look or not here, this is the ground switch, and it has a what we call a death cap underneath it. Kind of looks like one of these blue caps here underneath it, and so basically I clipped that out of the circuit, that guy right there, and this switch now is unpopulated. We went wiring wise, it had some electric tape, and I don't know what kind of wire was, junky kind of wire. Anyway, we put new wire in and heat shrink tubed it, and we went from the 3-wire grounded input. Since it's a grounded cable cord, we didn't need the ground switch anymore, so we just went directly to the AC outlet, fuse switch, and routed it behind here away from everything, and then up and under and up here, so to the power transformer. So that was the one thing that's done already. If we look at the schematic or layout rather, right here is where that death cap was, and this was the ground switch that we deleted, and we've already accomplished that. The ground switch here, we're probably just going to use it to be able to switch on or off this, I think it's, yeah, 2.7 K negative feedback resistor. So this just goes to this wire to the output jack, so we'll just interrupt it with that switch, so you can switch the negative feedback in, especially if you're playing at louder volumes, and if you're playing at lower volumes and want it to be a little bit more aggressive, you can have the option of switching that out of the circuit. Okay, so one nice thing is it has on the power tube sockets, I get my camera, it's got these precision 1 ohm resistors from the cathode to ground on both 6E6 power tubes. So that'll just make measuring the current of each tube individually, the bias of each one individually, and know exactly what each one of them is easily. You just measure across the resistor in millivolts, and that translates 1:1 to milliampere. So if it's 30 millivolts, it's 30 milliamps. Okay, so next, these orange electrolytics aren't original. They've been replaced, but we're just going to put fresh ones in. These are bypass caps in the preamp section, and we're just going to go ahead and swap them out. The other thing is, this is not, this was modified. So what we have here, first channel, actually the first valve, first triode, off the cathode we have a 0.68 UF bypass cap and a 2.2K resistor. Now the schematic calls for a 1.5K resistor instead of a 2.2K, and it calls for a 25 UF instead of a 0.68 UF bypass cap. So the larger the bypass cap allows more bass frequency to flow. This is similar to like a Marshall JCM800. They literally tried to almost voice this like a 800, because on an 800 this first cathode has a 2.7 and a 0.68. So they got a 2.2 and a 0.68, very close. On the schematic we have a 1.5K and a 25 UF, so a lot more bass is allowed to pass through. With Marshalls, they used that 0.68 to cut out a lot of the bass because they were overdriving it, and that frequency, if it's too low, the overdrive doesn't sound very good. So that's why Marshall did that, but that's what they did to this. And then here we have two plate load resistors that are supposed to be 100K. They're 220K. Sometimes people do that because it starves the plate a little bit, and it can cause it to break up, the tube to break up. It's not a pleasant sound to me. It's not how I like to get distortion out of a tube. So these go back to 100K. And then this slope resistor, it should be 100K, but it's 33K. So that's copied from the Marshall along with the 2.02 caps, coupling caps here. And that's on a Marshall, it's cathode fed, and it's a different type of circuit. This should be 100K, and then this should be 0.1, and this should be 0.04. Yeah, 0.047, so like 0.05. So yeah, 0.1 instead of 0.02 and 0.04 instead of 0.02. On a Marshall, they were both 0.02s, and it's a different circuit though. So somebody really tried to change this into like a Marshall JCM800 front end. These two caps, like if we look at the board again, this should be a 100K instead of 33K. It should be a 0.1 and a 0.047 here. And this cap here should be a 250p cap. And on our board we have a 470 picofarad. So that's what Marshall used also. And so this is going to all go back to stock. It's going to be 200K resistors, the 250 picofarad cap here, 100K slope resistor into a 0.1 and a 0.047 here going off to the tone stack, because they didn't change the wiring on the tone stack at all. And typically with the Marshall setup, There's a mid-range control in that also, but it's a different type thing. I think they were just kind of halfway copying what Marshall did, but it's plate fed. The signal is fed off the plate instead of where Marshall, they would feed it off the cathode. And they would also use a 10K cold clip resistor here without a bypass cap if they were going to do it completely like a Marshall. But yeah, just not. It's just not going to sound good with this type of setup for what this amp is. It would just be a nasty. I didn't play through it. The client played through it, and he didn't really care for it, and I don't blame him. I can only imagine what that sounded like, and with these two being the same value, you're just not going to have any tonal range from your bass and treble controls. That's why we put the 0.1, and the 0.04, to differentiate the bass and the treble. Other than that, I think that kind of wraps it up on what we're going to do. I've already ordered the parts, so when this will be a 2-part video. So I've already ordered the parts, so when they come in, we're going to get to changing all this stuff back to the way it's supposed to be. Just the electrolytic bypass caps, these orange guys, are going to be MOD electrolytics along with a MOD one here, and the appropriate value resistors and stuff in there. Other than that, everything else looks fine. Again, changing these two carbon comps to metal oxide. These resistors will be carbon film, just like these ones are. Not gonna mess with any of the carbon comps that are in play and some of the other parts of the circuit. As long as they measure within tolerance, we're fine. And yeah, that about covers it, hopefully, anyway. We're gonna put some F&T electrolytic caps in here, and like I said, I'm gonna stack these two on top of these two and just compact this a little bit better and neater, and that way it'll give us room for our bias trim pot here with a tail resistor to ground, and we'll be getting rid of that trimmer there, replacing that old 100 UF 100 volt cap. The schematic calls for like a 25 UF. 100 UF is fine because it's just a little better filtering. But yeah, and replace the diode with a 1N4007 diode, and then maybe change that out, but have it to the circuit specs as far as values go. Then I'll bring it up slowly and clean the pots, bring it up slowly, and start doing some measurements and testings after I get the new stuff installed. And we'll come back to a second video for that as soon as the parts come in, so that'll probably be 4 or 5 days from now when the parts come in. So hopefully that explains, especially to my client, what we found in this, and what we're going to do regarding the. And I've already talked to my client about this stuff that I found, and this is just kind of explaining why it's just not meant for this amp. We need, it's going to sound a lot better with a little bit more bass, more bottom end to it. It's a clean amp primarily, so it's going to sound better with more bottom end in it, and the tone and the bass and treble will work better. These 220K go back to 100K like they're supposed to be. But yeah, that should do it for this video, and once we get the parts and I get it wired up, we'll do a second video, and more than likely it'll be audio demonstration included in it.